Um, all right. Hello and welcome everyone to today's live stream, today's webinar. I'm Martin Dobias and I will be talking about 3D and digital twin improvements in QGIS 4.2. So let's get started. So digital twins. What are digital twins? This is like the ultimate buzzword in the geospatial industry, I would say. Everyone loves to talk about them, but the problem is often that different people are talking about different things when it comes to digital twins. So maybe it would be good to start about what they are and what they are not. So generally, the digital twins are meant to be like highly accurate replicas of the real-world physical environment. That's why like it's really meant a twin. So you have the real world. From real world, you have some data flowing to the virtual model, and then from the virtual model, ideally you also get some actions that like change how the real world works. That's the idea. That's the like highest level where we can get. The reality is that most of the time we are like very far from this big idea, and we are in like much earlier stages compared to like what people are like sometimes trying to sell to us. So if we are to like unpack the digital twins a bit, we can talk about like several levels of digital twins. So I would say the first level is like the descriptive one, where we have, let's say, some 3D model of a city combined with some other data from the city, from different departments, all of them like somehow harmonized together, that can be queried, and like that you can make some decisions based on that. But still, it's just like the static model. On the next level, then like we add some like diagnostic information. So this is adding streams of live data from various sensors, and this makes the static model to kind of live. The next level is predictive, where using all these data from level 1 and level 2, you add some predictive models, some AI that can like answer some like what if scenarios, if there will be some flooding in this area, if there is too much rain, and so on. It doesn't have to be AI, it can be even like traditional hydraulic models, etc. And then in the level 4, we are talking about like that the digital twin is also able to recommend some concrete actions, like I don't know, modify the way how the traffic lights work based on some situation in the city, and so on. And the level 5, which is like the ultimate autonomous digital twin, that it also like controls the physical world. So like this whole loop here closes. And like, to be honest, I would say we are still quite far from this level 5, and in reality most of the time we are somewhere at the level 1 or level 2. Often those who are selling digital twins provide some photorealistic 3D model with some let's say weather sensors bolted on top of that. Cool. What I would also like to argue about is that like digital twins, they are definitely going to be useful But in order to be useful, we should be like very careful about the platform where we build these digital twins. There are, of course, like various proprietary products that are meant to handle digital twins, but I would say they are very limited. One is that they often only cover one of the many aspects that the digital twin should be covering, let's say just like transport or just like some meteorological data and so on. They are often like very poorly extensible, that like if you want to bring your own algorithms to do some predictions, etc., that's likely to be difficult. Interoperability with data, to bring in data, to take data out, that proves difficult. And also there is the vendor lock-in, where it's difficult to move to something else. So what I'm trying to say here that there is a need for open platforms for digital twins that are based on open standards. Protocols, data formats, etc., so that we are not locked into one thing. And the other thing is to also be based on open source software, because that's what allows us to improve, combine things in arbitrary ways and get much higher value. And here I think there is a really big opportunity for QGIS to like be part of these open platforms for digital twins, because QGIS has really great functionality in terms of like being able to ingest and integrate almost any kind of data, be it any kind of raster, vector, point cloud data, meshes, and so on. Now, we need to be a bit honest about where we are right now with QGIS versus digital twins, because the expectations are really high. The problem is just like with the proprietary solutions, like the reality often lags. I'm sure many of you have seen this unfortunate QGIS dialogue when you try something and it doesn't work well and QGIS crashes. So with this in mind, being honest to ourselves, we knew that if we want to get QGIS to succeed with digital twins, we need to do something about it. And so we did a crowdfunding. So last year, Lutra Consulting, North Road from Australia, we have created the proposal for crowdfunding with the target of 75,000 euro. And we asked the QGIS community to help us out to support these new features. And we were fortunately successful thanks to many funders from the QGIS community. So I really want to say big thanks to everyone, to all the organizations, companies, and individuals that have contributed to our effort. And for the rest of the webinar, I would like to talk about like what are the things that we've done within this crowdfunding effort within the last less than a year, and how we think like the capabilities of QGIS are improving, especially in the context of digital twins. So one of the bigger pieces in our proposal for the crowdfunding was to support the scene layers from ESRI, or technically this is called the I3S protocol. So the scene layers essentially allow you to show like 3D model of some area, nicely georeferenced. So there is support, of course, for it in ArcGIS Pro, in their JavaScript clients, and so now we are bringing this as an interoperability feature that this will be available in QGIS as well. So QGIS already supports 3D tiles, which is very similar protocol compared to scene layers, and yeah, to improve the interoperability with ESRI, we've have added this one as well. So it's a new data provider in QGIS. It's there even since QGIS 4.0. This protocol is actually also OGC standard, which is a bit of a weird situation because pretty much there are like two competing standards from OGC for the same thing. So there are multiple versions. We are supporting everything that is I3S 1.7 or higher. So this version is already about 5 years old or so, but it's still possible to find some older data sets that are from earlier versions, and those unfortunately will not load in QGIS. We decided not to support them because the technical aspects were not very sound and the protocol was not very efficient. So, and the scene layers, they support multiple kind of layer types. So right now in this initial release we are supporting 3D objects and integrated mesh, but we have left out a bunch of let's say less popular layer types. The 3D objects and integrated mesh, they are both kind of similar, that like it's some kind of 3D mesh with georeferencing. The main difference is basically the integrated mesh. You can think of it as a mesh of the whole city from some photogrammetric processing from aerial imagery, while 3D objects, those would be typically like individual buildings, and each of the building could have some attributes assigned to it, etc. But not like a mesh that like covers the whole surface. So there are like several modes in the scene layers. We support both. There is the global and local, but both are supported, so you shouldn't have any problem with that. And there are like two main ways how you can access the scene layers. So most of the time you can find some ArcGIS REST servers online, and those you can use either from the browser dock or from the data sources manager. The other option is that you get a SLPK file, which is like a zip of the whole scene layer dataset, and that one you can also like drag and drop either from the browser dock or from the file explorer from outside of QGIS. And just to get an idea how it looks like, this is a scene layer from Prague, from their digital twin. So it all works quite nicely. Yeah, so that's like I think complements very nicely the support for 3D tiles that we already have. So you have like really nice, good 3D base map for your data. Next thing we thought is like very important for handling digital twins is to have good support for vector data in 3D. Like the 3D views in QGIS, they are already able to show vector data and like extruded polygons and so on. But there were quite a few issues with performance. And so we decided to tackle them one by one. First of all, we have looked at the tessellator. The tessellator is this magic bit that turns your raw vector data into triangular mesh that can be sent to your GPU to do the actual rendering in 3D. And what we did was we replaced the algorithm that was used before. Now it is more robust, so you hopefully shouldn't be getting any crashes, and it should be faster as well. We are using less GPU memory because we are using now the index buffers that were not used previously. And as an extra feature, we can optionally create also floors when we do the extruded polygons. The next problem that we had with, let's say, scalability of dealing with vector data is that previously we pretty much just tried to load all the vector data at once from the whole layer to your GPU. So this worked fine for small data sets, but it worked terribly with large data sets, and you could easily get crashes or like very bad performance. So previously we would just split like the whole layer into like 4x4 tiles and load all of them. Now we don't try to do that anymore, and rather we use like an adaptive approach. It's still tiling, but whenever we are producing a tile, we are also asking like, are there too many features? And if there are, like, we will not try to load all the features in that tile, but instead load just a part of them and then leave it for more detailed tiles to add more details. So when you start zooming in closer to the model, you will get let's say more buildings shown. And this like works very nicely. The only downside of this is that like you will not see, let's say, all the buildings at once from the whole city, but that's just not feasible to do with large cities without like a lot of simplification. Here on the top right, you can find there is also this parameter in the 3D render properties for vector layers, where you can choose what is the maximum number of features per each tile. So we are defaulting now to 1000, which hopefully should be like a good balance. All right, so those were like the performance improvements. The next thing is we have added the 3D symbols to the style database. So probably many of you know the style database, where you can keep various like 2D symbols and other kind of assets that you use for rendering. And so now that includes support for 3D symbols, be it point symbols, line symbols, polygon symbols. All of them you can keep there, and you don't have to recreate them every time, because we know it sometimes takes a bit of time to, let's say, load the model, set up the scaling, set up the axis and so on. So this simplifies things a lot. And another feature that was quite badly missing was highlighting of identified features. So that's here on my next slide. where you can see that like as you click for the identification tool, you not only get the highlight here in the 2D, but now also in the 3D view. So we chose to do like highlight with some like transparency, and then there is also this silhouette, which helps you to better see the object. And the highlight is of course always on top of everything, so even if it's hidden behind some other objects, it will be shown. Cool. And apart from, let's say, like the general vector layer improvements, we also did a bunch of work for improving support for 3D points. 3D points were especially painful to use if you wanted to use your own 3D models instead of just using some of the few predefined symbols like the cube or sphere or a few more. So if you had your own, let's say, OBJ or GLTF model, the 3D views would be getting like very slow, or they would be crashing with even like few hundreds objects. So we have greatly like reworked the whole rendering approach for points, and now we are using this so-called instance rendering. So rather than telling the GPU to like render this and render this and render this model many times, which is very inefficient, we are now just telling GPU, here is the model, here are all the positions where to put it, and do it 1,000 times or 10,000 times, and it will do that. And it's much more efficient, both from the point of memory use and also from the performance, and it doesn't crash QGIS. For this we also had to like rework on how we do loading of everything. So now we have our own loader for the OBJ formats and also for the GLTF formats. So from now on, these are the two formats that like we will be fully supporting, and any other formats for now are like not going to be supported. Another important addition is that you will be able to render 3D points with data-defined size, rotation, and offset. So you'll see on the next slide how that looks like. And the last bit worth mentioning is now for 3D points, we also support other materials than the Phong material or the Phong shading. So here's an example. On the left side, you can see a sample of a forest with randomly placed 3 points, but all of the models are exactly the same. On the right side, you can see that some of the trees are larger, some of them are smaller. So we've done this by setting the scale based on an attribute. So you can use this especially if you have the data where you have, for example, information about the tree size, the tree crown, then it's really going to help. All right, and switching from the vector data, to point clouds and LiDAR because in our opinion, LiDAR is also like very important source of data for digital twins. So you can have the terrestrial mapping, the aerial mapping, mobile mapping, all of that can provide a lot of data, and we need some way to process that. So within the crowdfunding, we have introduced couple of new algorithms to the QGIS processing toolbox. We are starting with noise filtering. If you have point clouds and like there could be some wrong reflections or some birds or anything like that, you can filter such noise so that it doesn't affect later stages of your processing. Then if you have the like unclassified point cloud, you can classify it using the Smurf algorithm. That will give you essentially two classes, like ground and non-ground. It doesn't support classification into more classes, like let's say buildings or vegetations and so on. This is something that could be potentially added further later. And then another useful algorithm is the height above ground, where if you take this kind of point cloud, the height above ground will essentially normalize the elevation that all the ground points are at zero, and from this you could then easily do measurement of how tall are the trees or buildings or whatever, even if the data are on a slope. And last but not least, there is also the transform algorithm that allows you to like move, scale, rotate an existing point cloud in case it is not well georeferenced. One more thing to note is that we have also added compare point clouds algorithm. It's using the algorithm called M3C2. This was outside of our crowdfunding campaign. It was funded by the Danish Agency for Climate Data, and it was in collaboration with Hobu, the makers of Poodle. And this algorithm really helps you to take 2 point clouds and compare them really kind of using the individual points. So you don't need to take your point cloud, convert it to raster, and then do the raster to raster differences. This one is like more robust to also some invalid data or to different densities of point clouds, and it's quite popular. Another extra improvement for LiDAR data for visualization in 2D is that you can do a bit of post-processing of the color. And so, for example, you can modify the color which is coming from the classified render and add some darkening, for example, using intensity. So you just use the QGIS expression to do that, and this is something you can get for better visualization. Cool. So in 3D map views, we have already for a couple of releases the support for cross sections, and Especially in cross sections, it's very useful to have orthogonal camera rather than the perspective one that is maybe more common for general use. But with orthogonal camera, you are not getting the perspective distortion, which you can easily see like here on the buildings, and then like the data you are trying to inspect and do some QA, it's much easier to understand. So just in case, you can switch the camera mode between perspective and orthogonal in the 3D map view settings. The fun fact is that like this setting has been there for quite a long time. Unfortunately, for many releases, it has been like completely broken. So now we finally took time to fix it, and so the camera control and everything else should like work much better with orthogonal camera. Then we did a bunch of like rendering quality improvements so that the visualizations are more pleasant to look at. One of them is addition of anti-aliasing. So on the left side, this is what you would get previously. Of course, this is zoomed in so that you can see the detail. So for example, for these edges, you would really just get like either like white or black pixels, but nothing in between. Now if you enable anti-aliasing, you get much nicer, smoother lines, and it's just more pleasant to work with. Another such improvement is the gradient background. So previously you would always get this default white background, which was not super exciting. Now you can also decide to use like this static gradient, where you would choose like what is the color on at the very top and at the very bottom of the canvas, and that's what will be used. This gradient, by the way, doesn't move with the camera; it always stays the same. And there are also a bunch of extras that like got into the QGIS 4.0 and 4.2 releases. So for cross sections now you can also adjust the tolerance. Previously you would always have to like pick 3 points, like the starting point, the final point, and then the width of the cross section. Now you can also like lock the tolerance to a particular size, and you just pick 2 points for cross sections. You can do nudge left and right the cross section so that you can easily see the neighboring area as well when doing the QA. There are many improvements to support of virtual point clouds. So if you have a large data set of, let's say, 100 or even 1,000 point clouds that you want to work together as like a single data set, so there have been improvements to editing and other bits. So I won't get into too much detail now because it would take us some time. Then you can also manually set the camera coordinates. So there's a small dialog that opens up, and you can explicitly set what are the XYZ coordinates, where you want to look at, from what distance you will be looking at that coordinate, and what are your pitch and heading angles. And you can also invert the y-axis of when doing the camera control with mouse. And from there are a bunch of extras also from North Road in QGIS 4.2. Some of them are really exciting. So there have been many additions to the physically based material. Then there are like greatly improved support for shadows. Often the shadows in earlier versions would disappear or would be of very low quality, so that should be now fixed or at least greatly improved. You can also set up sun as a light source of directional light source, where you can set a particular date and time and like intensity and few more parameters to get the sun direction, and so then also the shadows should reflect that properly. There is also addition of the skybox, so you can get a nice sky with some clouds that also moves as you move the camera. And a couple of more things like image-based lighting, the move towards the high dynamic range in the 3D rendering pipeline, the bloom effect that you can see like this textures, these buildings emitting light. So I'm very excited about all these additions. Cool. And let's talk about also about the future of QGIS 3D. So what's up next? We got a grant from QGIS.org to help us to move away from geometry shaders. This is quite like under the hood thing, like that hopefully shouldn't be even visible for users, but it's important for us to get rid of, let's say, the legacy stuff and modernize the engine. The other thing that we eventually want to look into is that the Qt3D library that QGIS 3D is based on, it is deprecated now. So eventually we will need to find some suitable replacement. And then we have a very long wish list of things we want to add or we want to improve. So maybe we will do some crowdfunding campaign. We'll still need to see what are our options. One thing that we are particularly excited about is 3D Gaussian splatting. So this is a technique that has been invented relatively recently, just a few years ago, and it is getting a lot of traction in the world because it offers like unprecedented fidelity for the data captures. So this, for example, is just like one small test I did recently with a cheap consumer drone. Just fly it in the neighborhood, and this is a result I got with like training the scene in cesium ion, and so I mean, like, look at all the detail and like the trees and all these very thin structures that like the traditional mesh model is really having hard time to capture. But here, you can see even like all the fences and like the basketball structures and everything. So it's amazing, like what this technology can do, or the thin tree trunks. So I think like this is something that should eventually get to QGIS as well to stay relevant. And this is something we would like to add at some point. So we are looking for potential funders that would be interested to help us to bring the 3D Gaussian splatting to QGIS. We would like to support 3D Gaussian splatting from 3D tiles format, because now there is this new extension to it that allows this kind of data, and it has been done in the collaboration between multiple companies, including ESRI. So it has like it is going to be like the industry standard, and yeah, the plan would be to have the 2D 3D renderer to handle that. The great thing is that like even nowadays you already have some also open source tools that you can use to take your imagery and get the scenes trained to Gaussian splatting scenes. Cool. So that's about it from 3D world and digital twins. I also have a quick update from our emerging maps team, which has been working hard on interesting stuff. And the most important thing I want to convey here is that now you can also use merging maps not just to do some field data collection, but also to very easily publish your QGIS projects online. So we hear this from our clients all the time, that the sharing of data from QGIS projects to like various stakeholders is still quite a pain, and there isn't a simple solution for that. If the stakeholder just needs to see a simple map without installing some desktop software and getting familiar with QGIS. So hopefully this will help to solve one of the big pain points of QGIS users. With this functionality, you can just push your data into merging maps and see the map online, and you can enable sharing of maps by link, and then you can send the link to anyone, and even without being logged into the platform, they are able to view the maps. So just like you would do with, let's say, Google Docs or something like that. So this feature is early access. So there is a button in Merging Maps dashboard. When you log in there, you can go and ask for access to this. And on top of all that, we have a functionality there which allows you to create your own small applications with JavaScript. So this, for example, is one try from my colleague to build like a personal tracking of runs, and so you can simply even vibe code a small application with the help of AI and get a nice web map out to your stakeholders. And with this, that's all from me today. So thank you very much. We have also the live chat here, and we have still a few minutes time. So if there are any questions, I'll try to answer them. So I'm looking at the chat, and if there are any questions. So there is a question: why not using cesium in QGIS via Q Web Engine View? Why not using cesium? Yeah, that's Actually, longer time ago, we were using a completely separate component. It was not cesium, but it was called Open Scene Graph and OSG Earth. The the problem was that the integration wasn't great, because these um, libraries or components, they rebuild a lot of stuff that QGIS already have, and then for example, getting the QGIS data to those platforms, it was quite difficult for interoperability and also for the consistency of the user experience. So that's why not something like cesium in QGIS, but I'm personally big fan of like cesium, like the work they are doing. It's great, and the JavaScript library is great. But I think it has like different use case. Then someone else is asking, I'm looking for a way of exposing the attributes in an existing 3D tiles dataset, usually called as batch table in the format. Is there an improvement on QGIS about this issue? Yeah, this is a very good point. So this is still on our wish list. So we are able to show the 3D tiles, but we are not accessing the attributes of the objects and not making them available through let's say identify tool. So it's something we are aware of and we would like to improve as well. A relation of this improvement with cesium ion integration from Luigi. These improvements, there is no direct relationship with the cesium ion integration. So for those who don't know, there is a plugin for QGIS for cesium ion. So those who are using this service to host their 3D data, it's possible to use it to easily get logged into the service and drag and drop the 3D tiles datasets into QGIS. So, but this is not related to that at all. And Kurt, okay, and Kurt is saying if he's holding a workshop on working with point clouds and QGIS. Yeah, awesome. With us, looking forward to that. All right, so I don't see any other questions right now, so I would conclude the webinar here. So thank you very much for your attention, and hopefully see you at some future one. Bye bye.